Today is 1.6. The last time you were here, we talked about Sig Fig identification. Today we're going to do some math with some significant figures. Let's get right into it. Adding and subtracting and multiplication and division. Those are the four basic functions that you'll do on a calculator with different measurements that have different numbers of significant figures. And you need to know which digits to keep, which digits to get rid of, how to round. Consequently, there are different rules for adding and subtracting and multiplication and division. With addition and subtraction, it all comes down to place values or decimal places. And you can only be as precise as your least precise measurement. Meaning that if you do addition or subtraction with two measurements, you have to round your answer to match the least number of decimal places that's represented by the original two numbers. Let's take a look at some math that'll show us how to do this. So here's a bunch of basic math problems. In this section, the math is not going to be the issue. The issue is going to be, do you know how to round these numbers correctly? So if you see this first answer, I'm hoping that everyone in here can just see that this would be 3.500, and that would be grams. So right now, based on our rules, we have 4 sig figs, because this has a decimal, so we could come from the left, we'd stop at the 3, 1, 2, 3, 4. It has 4 sig figs. But with addition subtraction, we're looking to the least number of digits to the right. This number has 1, 2, 3 digits to the right of the decimal. This number only has 1. What that means is our answer must be rounded so that it matches that and only has 1 digit to the right. We can only be as precise as our least precise measurement. If we look up at this next one, we'd bring the 2 down, we'd bring the 1 up, we'd bring the 1 up, and we'd get this number. The first number we were given has 1, 2, 3 digits to the right, and this number has 1, 2, 3, 4 digits to the right, meaning that our answer needs to be rounded to 3 digits to the right, so 3.81 would be how that rounds. Okay, things can get trickier. 1,000 plus 200 seems like a very basic math problem, but the issue is significance. We have significance to the thousands position here and the hundreds position here, meaning that we can only have digits to the least precise number, which would be the 1,000, and therefore this would round to back to 1,000, which just like all kinds of frustration, right? We just added 200 to 1,000 and then we rounded back to 1,000. We can only be as precise as our least precise measure. Now, some of the scenarios we're going to be giving you, like that one, those aren't going to really happen in real life all that often. We're really just trying to see, do you understand how to implement these rules? So we do this next problem here. We'd get an answer of 46.173. But this number is the least precise because it has 0 digits past the decimal, which means our answer should have 0 digits past the decimal, which means this one, we'd look to see if it rounds up. It will not, so this number would just round to 46. This next math problem, we'd get an answer of 57.207. But this 100 right here, there's no decimal, which means we would round this to the nearest 100. That's the least significant digits place for this number. So the 57 would actually round back to 100. So the key for addition and subtraction is to find your measurement that has the least amount of digits to the right, or significant digits to the right, and then round your answer accordingly. Multiplication division is a little different, and I would argue is probably a little easier. It's about the least number of significant figures. So instead of worrying about how far right the number goes, you're just going to count how many sig figs does this number have. And honestly, this is probably the way you're going to round mostly in this class, because most of what we do is multiplication and division. So if we take a look here, this is essentially 3 times 4. But if you would multiply this out on your calculator, depending on its rounding rules, you'd get something probably with extra 2 zeros on the end of that. 12 with 6 zeros. But this number has 5 sig figs, and this number has 3. So our answer needs to have 3 sig figs. 12.0. This number here would be 6 times 6 would be 36 meters, but we're only allowed to keep 1 sig fig because each of those numbers only has 1 sig fig. So this 6 would round the 3 up, and this would become 40. You cannot put a decimal place on that. If you put a decimal place after the 0, or excuse me, a decimal after the 0, that becomes 2 sig figs. So it's just 4, 0, and the 0 is not significant. This next one down here would work out to 1449.58, and 7.2 only has 2 sig figs. So we would round this to just 1400. This next one would be 91.584. But 5, the number 5, the measurement 5, only has 1 sig fig. So this can only have 1 sig fig, which is the first one, the 9. And then this 1 will not round up, so this would just become 90. And that would be meters cubed, because we multiplied meters by meters by meters. We're going to practice this a lot. It's going to take time for you to make sure you're doing the different rules for addition and subtraction, multiplication, dividing, but you can get it. And usually as kids continue to work on it, it usually becomes second nature and they just start doing it easily. In some situations, you're going to have addition and subtraction and multiplication and division. For instance, an average. In that situation, remember your order of operations. Do addition, subtraction first, and then multiplication and division. So for instance, if we add up all these numbers, we get 29.17. But these digits, since we just added, we would be looking to how many digits to the right. These all have 2, and the 29.17 has 2 digits to the right. So that we don't need to round that. We can just keep it that way. But to find the average, we then need to divide this by 3. When we divide by 3, we get 9.7233 repeating. We cannot have more significance in an average than we started with. These first numbers had 3 sig figs, which means our answer can only have 3 sig figs. So the 3 will not round the 2 up, and we would have 9.72 would be the average of these numbers with the correct number of sig figs. Here's another example. This is a little complicated, but we're just trying to show you how to remember the order of operations. So the first thing we do is subtract this, the 353, and these two numbers would add together to be 287.63. But now we need to round those based on addition and subtraction rules. This 900 only has significance to the hundredths place, meaning that we can only have significance in this number to the hundredths place, which means the 5 would round the 3 up, and this would round to 400. These two numbers, the 200 has significance to the ones position, which means we would take this 6 and round the 7 up to 288. So now that we've done the addition and subtraction and rounded correctly, we would now plug those numbers in for the division and the multiplication part. So we take 20.489 divided by 400 times 288, and that would give us 14.752. But notice, the 400 we rounded earlier only has 1 sig fig, which means, and that's the least number, and that means we should only have 1 sig fig in our answer. The 4 will not round the 1 up, and this will become 10. 10 would be the answer to this problem, even though we have lots of different numbers with lots of different levels of significance. We can only be as significant as the least significant number. This kind of goes on to explain everything I already just talked about, and we'd get 10 because 400 only has 1 sig fig. So that's all there is for today. It's just learning those addition and subtraction and multiplication and division rules. You're going to have to practice those. It's going to take time. If you run into a place where you're not sure what to do, come talk to me. Ask me a question. I'm here to help. Good job today. We'll see you next time.